Hey everyone, welcome. Today, we're going to dive into the world of data and demystify it a little bit. Our goal? To turn all those confusing numbers into clear stories that you can actually understand and, more importantly, use.
So, have you ever had that feeling? You open a spreadsheet or a report, and you're just hit with this wall of numbers, charts, and tables, and it feels like you're drowning. Yeah, if you've been there, you are definitely not alone. It's a super common feeling. But what if you could just learn how to swim in that sea of information? Well, that's exactly what we're doing today. We're going to take that overwhelming flood and turn it into clear, actionable insights.
So, our journey starts with a really fundamental idea here in Part 1, figuring out what kind of data we're even looking at. Because, and this is crucial, not all numbers are created equal.
The best way to think about this is to imagine a staircase of measurement. We're going to start at the bottom with some really simple labels and climb our way up to more powerful and versatile kinds of numbers. Okay, so at the very bottom of our staircase, we find nominal and ordinal data. Nominal data, that's the simplest stuff. It's basically just a label. Think car brands or your marital status. There's no real order to it. Now, one step up from that is ordinal data. Here, the order actually matters. Think about team rankings or a satisfaction score. You know that first place is better than second, but you don't know by how much. Climbing to the top of our staircase, we get to interval and ratio data. Now, these are the heavy hitters. Both have a meaningful order and a consistent distance between the values. The key difference, and this is the important part, is the idea of a true zero. With interval data, like temperature in Celsius, 0 is just another point on the scale. But with ratio data, like height or sales calls, 0 means the complete absence of that thing. That true zero is what lets you say things like, this is twice as tall as that. So, okay, why are we climbing this imaginary staircase? Why does any of this matter? Well, it's because the level of measurement you're working with literally determines everything you can do with your data. It tells you which calculations make sense and which ones don't. Getting this right is the absolute foundation of good data analysis. All right, now that we know what kind of data we have, we can move on to Part 2, finding the data center. This is all about discovering that one typical value that best represents our entire data set. Let's start with a question we've all seen before. If you have a list of student heights, what's the average? Simple enough, right? In the world of statistics, we just call this the mean. Now, you don't need to break out a calculator and punch in all those numbers by hand. Using a tool like Python, it's literally just one line of code. You tell it to find the mean of your list of heights, and boom, you get a super precise answer. In this case, it's 149.56.
But here's the thing about the mean. It can be a little sensitive. What if you have one student who's just exceptionally tall? That one number could skew the whole average. So to get a different perspective, we can ask a different question. What's the exact middle value if we line everyone up from shortest to tallest? That's called the median, and it's not affected by those extreme outliers.
And finding the median is just as easy. A simple command in Python sorts all the data for us and just plucks out the number right in the middle. No manual counting, nothing. For this group, the median height is 150. And finally, there's the mode. This one's the easiest of all. It's simply the most common value in your data, the one that shows up the most often. For our students, the mode is 152. And you can often spot it visually on a chart. It's usually the highest peak. Okay, so we found the center, but honestly, that's only half the story. Now we're moving to Part 3, understanding the data spread. This is all about asking, how clustered together or scattered apart is our data? See, an average all by itself can be really deceiving. Just look at these dogs. You could say they have the same average height. But, clearly their actual heights are completely different. That spread, that difference from the average, is what we call variance. To measure this spread with some precision, we use a couple of key tools, variance and standard deviation. They're basically just formal ways of calculating how far, on average, each number in our data set is from the mean. And yeah, those terms might sound a little intimidating, but again, we don't have to do the complicated math ourselves. We can just feed our student height data to Python, and it instantly calculates the exact variance and standard deviation, giving us a really clear picture of how spread out our data is. And now for my favorite part. We've classified our data, we've found its center, we understand its spread. So it's time for Part 4, telling stories with data. This is where we turn all these numbers into actual, meaningful insights.
Because let's be honest, a screen full of raw numbers, it's just noise. It's confusing. But a picture,
A good chart can tell a story with 1,000 data points in a single glance.
For instance, let's say we want to compare quantities across different groups, like how many students are from different schools. A bar chart is your best friend here. A few quick lines of code can transform our data into this super clear visual comparison, and you can instantly see which school has the most students. But what if you want to track something as it changes over time, like a student's performance across a bunch of tests? Well, that's what a line graph is for. This code whips one up, and it's the perfect way to visualize trends and see all the ups and downs.
And finally, to see how different parts make up a whole, like how much rain fell each month as a percentage of the total for the year, we can use a pie chart. This code generates a visual that's perfect for showing proportions, making it super easy to see which slices of the pie are the biggest.
And that brings us to the most important takeaway of all. Learning to work with data, it isn't really just about finding answers. It's about learning how to ask better, smarter questions. And that right there is a true superpower. So what questions are you going to ask with your data?